Hey Chem Kids, Campbell here. In our last video, we talked about reversible reactions in chemical equilibrium. And remember, when we reach equilibrium, the amount or the concentration of the reactants and the products aren't changing anymore, but they're frequently not the same amount. Like I don't have the same amount of reactants as products. So there's a way actually to represent how much of products we have compared to reactants, and that's called the equilibrium constant. We're going to learn how to write those equilibrium expressions, those KEQ expressions. And then in the next video after this, we're going to learn how to calculate them. KEQ is the ratio of the concentration of the products to the reactants when I'm at equilibrium. So that's what the EQ is, equilibrium. Now notice that these are in brackets because we're dealing with concentrations, and we're going to use brackets as a symbol for concentration, and the concentration is in molarity. So if you remember back to chapter 14, molarity is moles over liters. One thing that's true about KEQ is that it's dependent on temperature. So this equation and the amount that we're going to get, the KEQ value that we're going to get, is dependent upon the temperature. If I change the temperature, then that's all out the window. Let's look at how we set up a KEQ equation. So one thing about KEQ is that we're going to have to pay attention to those coefficients. You know, the coefficients that we put when we balance an equation. We're going to actually raise the concentration of the product or a reactant to the power of its coefficient. So what I mean by that is here's a reaction of sulfur dioxide. There's two, if we balance the equation, we get 2 sulfur dioxide plus oxygen gas yields 2 molecules of sulfur trioxide, SO3. So when we write the KEQ, it's the concentration of the product raised to the power of the coefficient over the concentration of the reactants raised to the powers of their coefficients. So my equilibrium expression for this is the concentration, so there's the brackets, of SO3 squared, raised to the power of the coefficient, that's my product, over the concentration of the reactant. So here's my SO2 raised to the power of its coefficient, that's why there's a 2 here, times the oxygen concentration. So this is something to pay attention to. Notice that these are being multiplied together, not added. So don't get confused because in the reaction we put a plus, but when we calculate it, we're doing a multiplication. We'll do some of the math in class though. All right, a couple more things. A homogeneous equilibrium is when all substances are in the same state. So they're all solids, they're all liquids, they're all gases. So for example, this reaction, these are all gases. So this would be a homogeneous equilibrium. What would the KEQ look like for this reaction? Well, concentration of the products raised to the power of their coefficient, there's none, so no power here, divided by the concentration of the reactants raised to the power of their coefficient. So here we go, raised to the power of 2. Did you guess that? The other type of equilibrium is called a heterogeneous equilibrium, hetero meaning different. So that's when I have substances in more than one state. So maybe I've got a solid with some gases or a liquid with some solids. So if they're in more than one state, they're heterogeneous equilibria. Now this is important because there's certain things that we leave out of that KEQ expression. Anything that's a solid, so has a subscript S, or a pure liquid, so a subscript of L, as their state symbols, you don't put them in the KEQ. The only things we put in a KEQ is something with that's a gas or something that's aqueous, dissolved in water. So for example, if we take a look at this reaction, I have ammonia chloride, which is a solid, in a reversible reaction with ammonia, which is a gas, and hydrochloric acid gas. So when I write the equilibrium expression, right, I multiply my products' concentrations raised to the power of their coefficient. There's not one, so it's not there. So here those are, over the concentration of the reactant. But here my reactant's a solid, so we don't put it in the expression. So not in the expression. So when I calculate the KEQ here, I just have to multiply my equilibrium concentrations of NH3 and HCl. Cool, no dividing. All right, let's see if you can write these equilibrium expressions. Pause the video and write them in your unit packet. If you did this correct, for our first equation here, we have a solid for a reactant. We also have a solid for a product. So those don't go into our equilibrium expression. We can cross them out. So we just have one product, which we're going to raise to the power of 2, over our reactant, also raised to the power of 2. So if you put bracket CO2 squared over bracket CO squared, you did that correct. For our next reaction here, we have two solids. One is a reactant and one's a product, which means I only have one thing in my KEQ. So your KEQ should just be brackets around CO2. So the KEQ is just the equilibrium concentration of carbon dioxide. All right, last one. How'd you do? Break out, so you got two solids here again. Those don't go in your equilibrium expression, so I just have zinc plus 2 in brackets over copper plus 2 in brackets. Now notice there's no power here. The powers would be the coefficients, not the charge. Don't confuse charge with the coefficient, so that's not squared. It should just be the concentration of zinc plus 2 over the concentration of copper plus 2. All right, last thing with writing equilibrium expressions is that we have to go backwards sometimes. So we've so far taken a chemical reaction equation and written a KEQ expression. Now we're going to go backwards. We're going to take a KEQ expression and write the reaction equation. Well, remember, it's always products over reactants raised to the power of their coefficient. So we're going to start on the bottom. So we're going to start with here our hydrogen. So we're going to write H2 plus I2. Now remember, in the KEQ, we're multiplying them together, but in the reaction equation, we use a plus to say that we're putting these things together, we're adding them together in a beaker. And then we put our, remember it's a double arrow, so however, that's an ugly double arrow, but however you want to put your double arrow in, there's a double arrow. And then on the top there we have our product, so we have our HI. But don't forget that these powers are their coefficients, so that's the number in front. So there we have our hydrogen gas plus our iodine gas yields 2 hydroiodic acid. All right, let's do this one down on the bottom. In fact, why don't you try it, pause the video, and then check and see if you got it right. All right, on the bottom we have our methane, our CH4, plus 2 oxygen gases. See, that's O2, right? The 2 of the O2. Again, double arrow. Again, however you want to write your double arrow. I'll write it a little differently that time. And then we have our carbon dioxide plus 2 waters, H2O. All right, how'd you do? Time to work on some problems.